Perfect. Okay, so yesterday was more, I think, easier, and we learned a few formulas, maybe the distance formula for some of you forgot, midpoint formula, but today is more focused on just angles. All right, now, if I ask you to define an angle, all right, can anybody define what an angle is? And first we can draw an angle, and that's how we should start. All right, how do you make up an angle?
Like the three things that make it up.
With what three things?
Like Q, right? Like Q.
No. You're thinking of describing that angle. What is it made up of? A point and two lines. Not exactly. I don't see two lines anywhere.
No, two rays?
Yes, it is. All right. So believe it or not, the fancy definition of an angle is this right here where the two rays meet is called the what? The vertex. That's exactly right. All right. So an angle is just two rays that share the same endpoint. All right. I'm not going to ask you for that definition. All right. I'm just telling you that's how someone would define an angle. All right. Now, someone did say something earlier about the different types of angles, and I'm sure everybody remembers that. All right. So now if we look down here, name the vertex of each angle. So angle 4 would have a vertex of what? And it's just a point. Yes, T. That's it. That's how simple. All right. And angle 1 we say is vertex what? W. Yes. And angle 2, help me out.
C.
And 5 is also what? T. Does everybody understand now why you just can't say angle T? Would anybody know what angle we're referring to if we said angle T?
No.
No. All right. So generally when you refer to an angle, all right, you would say, for example, angle 5, you would say is angle STW. The middle letter is always the what? The vertex. Exactly. All right. Now, could I say angle 4? And you would know what I'm talking about, correct? So you could say angle 4. All right. You could say angle STU, angle UTS to call angle 4, correct? Now, there are going to be times when you have, when you have an angle and you can define it as just A. Like if I say that's angle AB, or if I say that's angle BAC, you can actually just call that angle what? A, right? Because that's the only angle A available. All right. But if you can't decide what angle it is, you have to name the angle with 3 letters. Or if there's a number on the inside, you can call it angle 1. All right. Hopefully it's just basics here, guys. All right. So now name the sides of each angle. All right. Angle 4. What is angle 4? What are the sides of angle 4?
SQW.
Someone?
SUW.
Angle 4. Maybe I'm not seeing it correctly. Here is angle 4. Do you agree? What are the sides of that angle? Say it. What are the sides of an angle called? Ray. So you have to name it as a ray. What are the 2 rays? I agree with TU. All right. So you would say TU and you'd identify it as a ray. And the other ray is what? Yes, TS. Notice I can't say ST. ST is not the same ray as TS. Does everybody agree with that? And remember, if you don't know, just tell me. All right. Everybody's good with that? Does everybody see ray TS is not the same as ray ST? Is there a ray ST? There is no ray ST. All right, so now you can tell me angle 5 is made up of what? TS and TW. All right, now for number 7, we can just say without even looking at it. All right, this is something a lot of kids make a mistake on. Without even looking at the picture, what are the two rays? TS and TV, right? Because we know that T is the what? Vertex. Make sure you know that. And again, angle 1 then we would say is what? Ray WT and WV. Agreed. All right, now you just have to write another name for each angle. Angle 3 could be called angle what? Angle 3? Angle, man. Sorry, angle 3. Say it again. Yeah, WTV, right? This is angle 3 right here, right? That's angle 3, right? And what's the vertex? T. So you would say either WTV or VTW. All right, I don't care how you label it. All right, now let's get the next one right. Angle 4 can be called what? ST what? U or UTS. WTS could be called 5 or STW, right? Okay, angle 2 can be called TVW or WVT, however you want to write it. Everybody's good with that, right? All right, here we go. Classify E. What does right mean? Acute. Less than 90, obtuse. Now, technically, obtuse is less than what? 180. All right. Less than 180 and greater than what? 90. All right. Soon you will learn that there's angles greater than 180, but right now you don't really know that. All right. But there are angles greater than 180. All right. Now, this little symbol right here is what? That's the right angle. Okay. That's the right angle. All right. So let's see if you guys remember. All right. NMP. Yes, right. OMN. Acute. QMN. QMO. Yeah, it looks obtuse, but do I really care? No, because it's too hard to see, but it does look a little obtuse. All right. Now, what they wanted you to do was actually take a protractor and measure that, but we're definitely not doing that. All right. So if it doesn't have the right angle symbol, then it's not, you can't say it's a right angle. All right. So that one I have to fix. Fix that, please. Okay. So let's go down to now. So let's review. What does bisect mean? In the middle, right? But it says that BD bisects EBC. So let's find BD. All right, so here is BD. And what does it bisect? So what does that do to EBC? Yeah, it does definitely makes it smaller, but what's true about EBD and DBC? Yeah, they're definitely acute in this picture. But what does bisect mean? Yes. Wow, maybe that's my fault. Bisect means what? Cuts into two equal angles, right? You can bisect a segment. That just means cut it in what? cut it in half, 2 equal parts. When you bisect an angle, you cut it into what? 2 equal angles, 2 equal angles. That is correct. All right, now how do you mark those 2 angles are equal? This way, here, and here. Right? So now I need someone to discuss segment addition postulate using A, B, and C right here. Someone write the segment addition postulate using this A, B, and C right here. You are awesome, buddy. Thank you. AB plus BC equals AC. That's the segment addition postulate. Now, why did I remind you of that? Because the new postulate today is the angle addition postulate. So tell me, use the angle addition postulate with EBC with this right here. Say it again. No. Walt. That's how easy. And who doesn't know that, right? We used to call this common sense, right? If you don't know that, we're in a little bit of trouble, right? That's called common sense. That's what we used to call it. All right. That's common sense. So the angle addition postulate, I always laughed. You cannot prove that's true. All right. No way to prove that's true. All right. So the angle addition postulate is, again, the sum of the 2 parts equals the whole. But in this case, you could say angle EBD plus DBC equals EBC. Is everybody with me on that? Do I need to explain what postulate is? Everybody remembers what a postulate is now, right? Postulate is things that you have to accept as true based off observation, right? Theorems are things that you can prove are true. All right, so that's the big deal today, the angle addition postulate. All right, so now let's look at number 17 and see what it says. So you mark EBD 4x plus 16. So I'm going to write on my figure 4x plus 16. And then what?
Is it really supposed to be find angle EBD? Because it already says it.
What are you talking about?
It says find EBD when it says what EBD is.
Find the measure of EBD.
Oh.
That's what this little m means. Find the measure. All right. What does DBC equal? 6x plus 4. All right. So now, someone write me an equation. Wow, you guys are, I mean, what? Go.
4x plus 16 equals 6x plus 4.
Yes, thank you. 4x plus 16 equals 6x plus 4. Beautiful. All right, and because we are experts, we can do the mental math. Did someone else agree x equals 6?
I agree.
Okay, is that the answer? No, not this time. All right, we have to go back and read the question. It wants what? Of EBD. So EBD would be 40 what? 40 degrees, right? You measure angle with degrees. 40 degrees. Anybody have any issues with that? Tell me. We just found what? See this right here? EBD, right? It's 4x plus 16.
Oh.
Right? X is 6. Do you agree?
Yeah.
All right. Now, someone tell me real quick, what's DBC?
Mm.
40, right? We already know they're equal. So if I said, then what's EBC? Everybody would say it's what? 80, right? That's how easy it is. All right, very, very easy. Now, again, these problems are kind of important, again, because they come up all the time on the SAT and ACTs, all right? These angle problems. All right, so now let's look at 18. Now, oh man, I left something out. No, no, I didn't. BD bisects EBC again. All right. I wanted to make sure that's there. Right. So this one's a little bit different. All right. So EBD is still what? 4x minus 8. Now this time they're telling me that what? Right. So how you mark that is this. This would be 5x plus 20. That's how I like to mark it. All right. So now I need help with an equation on this one.
Can you do 8x minus 16?
Of course. 8x minus 16 equals 5x plus 20. How did you do that? Yeah. Does everybody see that, right? That wasn't that hard. Now, of course, we're brilliant, so we can just go ahead and tell me that x equals what? X equals 12. Come on, guys. Let me know you're with me. X equals 12. Now, of course, that would be a multiple choice answer on your test, and everyone would circle 12, and then they would all get it what? Well, it depends on the question, right? So here it says, it does say find the value of x. So we found the value of x, but they also say find what? Right? The measure of angle EBC. All right, so that would be what? 80 degrees. All right, is everybody with me now? I'm just telling you on the test, you have to answer the right question or it's wrong. All right, so there are always multi-step questions. All right. Now let's quickly review opposite rays. What is an opposite ray? Why are CB and CD opposite rays? Because they're opposite directions, but from the picture, what does that actually mean though? What can you tell me? They're, in this case, yes, they are vertical, but what's true about this measure from here to here? 180 degrees, right? All right. And again, that 180 degrees is just completely made up. A long time ago, the Babylonians, when they first figured out the circle, they just said, wow, we're going to make it 360 degrees because 360 degrees is divisible by so many numbers. All right. Later on, they came along and they decided to measure it differently using radians, all right, which you'll learn a little bit later in life. But right now, we only have one way of measuring, all right, that's with angles. And for some strange reason, they just decided to make it 360. If I was in charge, I would have just made it what? 100. All right, it would be much easier. All right. But they decided to make it 360 simply because lots of numbers are divisible by 360. All right. So with that being said, opposite rays just mean that it forms a line. All right. And because it forms a line, all right, we know that that is 180 degrees. So now we're going to draw everything in the figure. CE bisects DCF. So mark your figure appropriately. CE bisects DCF. So I make this line right here, and I put a tick mark here, and I put a tick mark here. CG bisects FCB. So here we go. Right here, 2 tick marks, 2 tick marks. All right. Now, what I want to do, because I just saw this, it was kind of great. It's kind of interesting. The SAT now. I want someone to tell me what the measure is of GCE. What does that have to be? Oh my goodness. If that's for you, go. Yes, let me see. All right, sure. Tanner, you interrupted my class today. Hurry up, hurry up, hurry up. So you don't miss this great explanation. Did anybody figure out what these two angles must add up to? Somebody take a guess? Good. What? 90. Does anybody agree with that? Does it look like 90? It does? Okay. Let's figure out why it's 90. Let's figure out why it's 90. All right. So this angle over here, right here, do we know what that angle is? So we'll call it what letter? X. Do we know what this angle is right here?
No.
So we'll call that what? Nope.
Oh, X again.
X again, because why? They're equal. Come on, everybody needs to pay attention on this. All right. Now, do we know what this angle is down here? So we'll call that what? Y. So what's this FCG going to be? Y. Now, because we just learned something about the angle addition postulate, all four of those angles are going to add up to what? 180 degrees. So now write me the equation for that. 2x plus 2y equals 180. Brilliant. So now what can I do? Divide by 2, and we get what? X plus y equals 90. So does it matter what we use there? No. Those two angles will always add up to what? Those two angles will always add up to 90. So that, in fact, is a right angle. That's kind of like your first proof. All right, that's kind of like your first proof. All right, we'll get to much more details on that. That was kind of nice. All right. Anybody have any questions with that? All right, so now let's go back to question 19. So now I'm going to erase this right here. And I want someone to tell me what is DCE.
4x.
Yep, so let's write it in there, 4x plus 15. And what is ECF? 6x minus 5. So what's true? They're equal, right? So let's just go ahead and practice our mental math again. 6x minus 5 is equal to 4x plus 15. And we end up with,
X equals 20.
do we agree? Say it, come on. X
equals
equals 10. Right? X equals 10. Now it says find the measure of what? DCE. So what's DCE?
10.
Say it again. How much? I think he's right. 55 degrees. Everybody's good with that? I told you that's easy. All right, circle 20. Let's come back to that. I think it's the same thing. All right. All right, here we go. Okay, so here's a map. What kind of angle do Central Street and Spring Street make? Yeah, does everybody agree with that?
Mm-hmm.
Central and Spring, this is a 90-degree angle. Valerie is driving down Spring Street, heading east. She takes a left onto River Street. What type of angle does she have to turn her car through? She's going east, right? So I'm assuming you know this, right? East is going this way, right?
Mm-hmm.
And then she turns which direction? Left, so that means she's going
45.
this way, right? What type of angle is that?
Acute.
Acute. I think that's all they want. Okay, so now they want you to figure out, calculate what that angle is. And how do I calculate that angle?
You get 2x equals 4.
No, no, no. Come on, someone. How do I write that equation? Come on, this relationship. Go.
So you like put x plus 8 next to 3x plus 12.
No. And do what?
And then you like offset like it'd be 3x squared.
No, 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 no. No, no. First of all, 3x plus x, remember, is 4x. But you're on the right track. When you add them up, they're going to add up to what, Aiden?
4x plus 20.
4x plus 20 equals what? Come on, someone else. Tell them. Yeah, of course. Come on, guys. That's these two angles are 180 degrees, not 90, right? So we say 4x plus 20 equals 180. Is everybody good with that? Because it makes a line. You agree with me? Makes a line, right? So 4x plus 20 equals 180. So tell me again what x is. What is it? 40. So what angle did she turn at? How many? 48 degrees. She turned her car at 48 degrees. What class did I have you for last year? What period did we meet? Yeah, it's like the very end of school, right? You guys got to wake up now. Come on. Let's go. Well, we're looking at this angle right here, right?
Yeah.
So what's x?
40.
So you're having trouble with 40 plus 8? You with me now, right? All righty, here we go. Next lesson. And we already did this also. Vertical angles. Name 2 acute vertical angles. Does anybody remember vertical? Make an X. Vertical angles are the ones, what? Directly across from each other. And vertical angles are always congruent. Vertical angles are always congruent. So name 2 acute vertical angles. Someone help me. What? Yes, very good. Thank you so much. HKE and FKG. Those are acute vertical angles. Name 2 obtuse vertical angles. Bless you. FKE and HKG. Very good. Now, come on. These are all just definitions, guys. And I know it's early in the morning. So you got to, if you don't ask me, I can't help you. Right? So if you're not telling me you don't know the definitions, you got to let me know. All right. Now, what do you think linear pair is? What's the root word here? Line. So it just must be 2 angles that make a line. What are 2 angles that make a line? Say it again. EK. There's got to be 2 angles that make a line. Someone help him. Hold up. Say it again. Go. 3 letters make a line or make an angle. I need 2 angles that make a line. So for example, up here, guys, on my X up here, this angle and this angle form a linear pair. These 2 angles form a linear pair. These 2 angles form a linear pair. And these 2 angles form a linear pair. Agreed? All right, I don't know. So now someone tell me, give me 2 angles that form a linear pair on this figure here. Angle what? G, K, GKE is a line. You keep saying GKE, that's a line. GKF, hold up. So we'll go with GKF. So GKF, now I'm going to highlight it. This right here. GKF along with what? H. What? Say it. Speak up, please. Yes, EKF. Thank you. Angle EKF. Now I'm going to highlight it. This right here. Do those two angles make a line? Yes. So you could do the same thing on the other side, right? You could say EKH and HKG. Does everybody agree with that? All right, look up because you guys didn't do a good job on that. So you can also say HKG and FKG. So everybody good now? Everybody see two angles. Now, technically they say share a common ray. KG is the what? Common ray. They have to share a ray in order to be linear pair. Okay? Now, what do those two angles add up to? What do those two angles add up to? 180 degrees. All right? You just learned the linear pair postulate. All right? You just learned the linear pair postulate. We'll talk about that a lot. Okay. Name two acute adjacent angles. Now, what does acute mean? Less than 90 degrees. Adjacent means right next to each other. So what two angles are next to each other that are both acute? Yes, thank you. JKG and, bless you, FKG. Those are acute adjacent angles. Everybody good with that? Name an angle complementary. Complementary means two angles that add up to what? 90. Supplementary are two angles that add up to what? 180. I always tell kids, remember that by alphabetical order and numerical order. C comes before S, 90 comes before 180. All right, so I need two complementary angles. And you could just say C number what? 25. Right? Does everybody agree those are complementary angles? Because of that 90-degree, right? So this angle plus this angle is complementary. They add up to 90. Do they have to be right next to each other to be complementary? No. All right, so now supplementary. Supplementary, C number what? 24. Because if they form a linear pair, they are what? Supplementary. Does everybody hear me on that? If they form a linear pair, they have to be supplementary. All right, everybody's good, right? Find the measure of an angle and its complement if one angle measures 24 degrees more than the other. Ooh, this is a great one. Good algebra. Everybody put a star by this one. This one's probably on the test, I think, if I remember correctly. Find the measure of an angle and its complement if one angle measures 24 degrees more than the other. What is it, smarty pants?
90 equals 2x plus 24.
90 equals 2x plus 24. Okay, that's really good. I thought you were just going to tell me the answer. How did you get that? One angle is what? No, I don't want the answer. I want the equation. One angle is what? That is correct. That's how you guys should be thinking about it. One angle is x. One angle is x plus 24. And those two angles add up to what? So don't even solve it, please. 2x plus 24 equals 90. I know everybody can solve that. All right, I'm not interested in that. All right, that was number 28. All right, now number 29. Let's try to set up 29. Everybody try to do what he just did. So someone help me. All I care about is the first angle is what? And the second angle would be x minus 36. So the two angles together equals 180. I know you can solve that. Okay, let's look at 35. Let's try a couple of these tricky questions. What time's the bell ring? I forget. I don't know these things. Does anybody know what time the bell rings? I should know that. I just don't want to give you a bunch of homework. So 41. All right, so we got 5 minutes. All right, so here we go. We all should be able to figure 35 out just super easy. What's the measure of angle 1? How much? 120. What's angle 2 and 3? 60. Anybody got any questions with that? Anybody? All right, vertical angles, supplementary angles, all kinds of things involved there. All right, let's look at 36. What are those two angles called? 1 and 2. They're definitely acute. They're adjacent. Somebody give me another word. What do they add up to? So they are complementary. There's just so many different words. That's what sometimes it makes it more difficult. All right. So I like everything you said. They are adjacent. All right. They are acute. They are complementary. All right. All of that is true. All right. Here we go. Number 37. Interesting problem. Come on, figure this one out for me. Did you get it? Did you get it? What did you think? The two angles, the measure of the two angles are what? Yeah, that's so easy, guys. 2x plus 3x equals 90. Come on now, you guys. I don't want you just writing things down after you see someone doing it. You try it first. That's what I'm asking. You try it first. All right. So obviously x is what here? I think it's 18, right? All right, now we know x is 18, but we want to find the measure of each angle. So the angles are what? Yes, 36 degrees and what? 54 degrees. Okay, let's just go over here real quick. I have just another minute and we'll call it a day. All right, 39. All right, what's angle 2? Just look up on the board, guys. You don't have to look at your paper. What's angle 2? Everybody should see that. 135. What's angle 3 and 1? Girls, please tell them the answer. Angle 2 is definitely 135. How much? 45. How did you know that? Yeah, they add up to 180. What's angle 3? 45. And of course, angle 4 is what? No. Angle 4, someone help him. How much? Now, it doesn't say they're equal. Now, those of you guys who said it's equal, I'm saying it's okay. It would be 50 if it marked it equal, right? But they're not marked equal. But because this is a rectangle, this angle down here must have been what? A right angle. So the other one is what? 40. All right. Now, just to make sure, guys, I know the first chapter is kind of boring because we're just doing definitions and reviewing. All right. You have to know the words. All right. You can't do geometry if you don't know what the words mean. Right? Does everybody understand me? So again, I don't care what you do this weekend. I'm not going to assign really any homework. But if you don't know these words, you don't know these definitions, if you don't know these 3 lessons, it's going to be kind of hard. Does everybody understand that, right? It's just definitions at this point. Few basic little simple equations. That's it. But the definitions are the most important thing. All right. So no homework. I'll see you guys on Monday. Great job. Man, you guys, we got to wake up in the morning. I may have us do some calisthenics or something in here, right? You'll be running around the room. All right, you better wake up. Yeah. All right, good job, you guys. Have a nice weekend.
All of them.